Good evening, students. Today we will learn about molecules. How the molecular formula is written, how the molecules are formed, how the element combines to form molecule. For that, element have their valency, the element form the ions depending on their combining capacity or valency. Then these ions combines together to form the molecule. So for molecule, one of the important characteristic, how much atoms are present in that molecule. So that one is called atomicity. So today we will learn about molecule, atomicity of a molecule, then formation of molecule. So these things we will learn today. A student, in last class we have learned about the atoms or the elements. So elements are represented by their atom. Means one element is represented by one atom, and this atom have a characteristic called atomic mass, which tells us how much heavy is that atom. Say one atom, the mass of one atom is taken, it is called as atomic mass. But the mass of one atom is so small that it cannot be measured by any of the balance. It is of the order of 1.6 into 10 to the power minus 24 gram. So this is called 1 AMU. Therefore, a group of atom is taken which can gives the mass in term of the gram. So that group of atom must be 6.022 into 10 to the power 23 atoms. If we are taking this much atoms together, then its mass will be in term of gram. So collectively, the group of or the mass of 6.022 into 10 to the power 23 atoms is called as molar mass. So we have learned this could be for one atom. So it is called as simply atomic mass in AMU or denoted by U. But in place of one atom, if we are taking 6.022 into 10 to the power 23 atoms, so collection of this much atom is called 1 mole of atom. So mass of this 1 mole of atoms comes in the term of gram, denoted by G. And we have also learned there is a relation between AMU and gram. We have learned 1 U is equals to 1.6 into 10 to the power minus 24 gram. Or in term of kg, it becomes 1.6 into 10 to the power minus 27 kg. So here we are observing the mass of an atom is very, very small. So one atom means 1 U, means only this much. But if we are taking 1 mole of atom, means 6.022 into 10 to the power 23 atoms together, that will give us in the unit of gram. Example, say we have written last day one atom of hydrogen. Its mass is 1 U. But if we are taking 1 mole of hydrogen atoms, means how much atoms of hydrogen we are taking? 6.022 into 10 to the power 23 atoms of hydrogen. then its mass become 1 gram. So we had observed there is a number for each element or for each kind of atom. So if we are considering only one atom, the mass would be given in U or AMU, atomic mass unit. And if 1 mole of atom or 6.022 into 10 to the power 23 atoms are collectively taken, then it become in term of gram. If we are taking say 1 atom of helium, then its mass is your 4U. But 1 mole of helium atom, mole, a student, means collection of this much atom. Okay, like dozen we are speaking means collection of 12. So rather than writing 6.022 into 10 to the power 23, we are using the term mole. So 1 mole of helium atoms, so its mass become 4 gram. So only, yes, so only the unit get changed. The number, the numerical factor, like 4 here, it will remain unchanged. Similarly, if we are taking the sodium, say for sodium, if we are considering 1 atom of sodium, denoted by Na. This symbol we had also learned in last day. If you have any doubt, please go and refer that videos. So 1 atom of sodium, its mass is observed to be 23 AMU. But if we are taking 1 mole of sodium atom, yes, what will be its mass? So it becomes 23 gram. Here 1 mole indicate we have 6.022 into 10 to the power 23 atoms of sodium. Okay, it means this. So last day we have learned about how is the symbol for each element. So that table, what are useful for you? What are the various symbols that you have to keep in mind? In the same table, we shall keep this atomic mass also in our mind. Student, so let us go for that table where we had last day we were writing the symbol for each element. Student, there are total nearly 120 element, means 120 kind of atoms, but remembering all those are not important at your level, but there are certain elements which are used most frequently. So their atomic mass and their symbol you need to keep in mind. Okay, student? So what they are, I am going to write those things. Student, here we need to keep in mind. So let us go in that table what we had learned in last lecture. Student, the important elements and their symbols here we had written. So for hydrogen, H was the symbol. How this symbol was given and how is all those things that we had also written. In front of this, today I am going to write how is their atomic mass. Atomic mass in the black ink. So hydrogen, the serial number, or basically called the atomic number, this we will learn later, or the lightest element, or arranging according to their weight, hydrogen comes first. So serial number for hydrogen is 1. The mass is also found to be 1U. A student, here I am writing U means mass of 1 atom. But if we are taking Avogadro number of atom, say here I have written mass of one atom, then it is given in the term of U or AMU. But if we are taking Avogadro number of atom, means 6.022 into 10 to the power 23 or 1 mole, then it will be in term of gram. So this difference you have to keep in mind. Okay, student? Now, so for hydrogen, you have to keep in mind the mass of hydrogen is 1. So 1 U or 1 gram. 1 U means mass of one atom of hydrogen, and 1 gram means mass of 1 mole of hydrogen atom. Okay, student? It is this one. Similarly, for the helium, we have to keep in mind the mass of helium is 4. So I may write 4U or 4G, but I prefer here to write U only. Okay, student? So this thing we have to keep in mind. Now coming to the lithium, a student, for lithium, the mass of one atom is found 7 times heavier than hydrogen. Means it is 7U.
7.
Good. Now coming to the beryllium, the mass of beryllium means beryllium is found to be 9 times heavier than hydrogen. So its mass is 9U. Student, this number you have to keep in mind. You have to keep 2 things in mind. One is their serial number or called atomic number. So which element comes after which? Another one is considering their mass. Okay. Here we are observing the serial number increasing, the mass is also increasing. The serial number, basically the atomic number, is more fundamental, and that decides which kind of ion it will form. So those things we will also learn today. Now coming to the boron, if we consider the boron, it is found that boron is nearly 11 times heavier than hydrogen. Means it 11 is your 11U. Coming to the carbon, we had already learned while defining the AMU that the total mass is 12. For 1 mole of carbon is 12 gram. With the help of that, mass of one atom is 1/12 of the mass of one atom of carbon. So it was our 12U. This thing we have to keep in mind. If you have any doubt, you please refer the previous day video. Now coming to the nitrogen, it is found 14U. Coming to the oxygen, it is found 16U. A student, you may recall, last day we were considering the reaction of carbon and oxygen to give carbon dioxide. Oxygen exists as O2, we were considering like this. There I was frequently writing the mass of carbon as 12 gram because it was taken in gram. So this was in term of 1 mole of carbon atom. For oxygen, a student, how much I was writing for O2? Can you recall? I was writing 32 gram, not this 16. Why? Because this O2 is here, means twice the oxygen. So for oxygen, it is our 16, therefore it was multiplied by 2 because of these 2, and it was coming at 32U or 32 gram in our reaction. Okay, student? So this thing we have to keep in mind. So whatever this number I am writing, though we had used in our earlier classes, but we have to keep all these number in our mind for the reaction. Okay, so the same number I was taking earlier. Now coming to the fluorine, it is found that mass of fluorine is 19U. Now coming to the neon, mass of neon is found to be 20U. Coming to the sodium, we had already written. Sodium is how much? Student, mass of sodium? Tell me quickly.
23.
Very good. It is 23.
23.
Student, please do not sleep. While I am asking, you please quickly respond so that I can also understand that you are learning. Now coming to the magnesium. Magnesium is found to be 24. U. Coming to the aluminium, it is found to be 27 U. Coming to the silicon, it is found 28 U. Coming to the phosphorus, it is found 31 U. Coming to the sulfur, it is found as 32 U. Coming to the other element like our chlorine, it is found at 35.5 U. It is the fractional one or in decimal. This we need to keep in mind. A student, coming to the argon, it is found to be 40 U. Coming to the potassium, it is found as 39 U. Coming to the calcium, it is also found to be 40 U. So barium, bromine, copper, no need to mug up for all these things. Like iron, it is 56, gold. For other, this number is not required. Okay, up to 20 you need to keep this in mind. A student, here we are observing one thing. What is our observation? Observation is that whatever the serial number, so it is roughly doubled. So slightly higher or slightly lesser, but roughly doubled. So if you are able to remember this serial number or atomic number in your mind along with this symbol, the mass you can roughly tell that will be near to that. Potassium slightly lesser than, so it is slightly higher than their atomic number, double of atomic number. 19 into 2 is 38, but it is 39. This argon, okay, it is also 40. These things are observed or determined practically. Chlorine, it is the fractional. So this is important one, a student. For chlorine, we will use this again and again. For other, so for hydrogen, again, for hydrogen, it is not double. So atomic number and mass number, both are same. But we will learn later, hydrogen exists in 3 forms. They have different masses. The normally existing hydrogen have mass 1 U. The other type of hydrogen also exists which have mass 2 U. The another one kind of hydrogen exists with mass 3 U. But normally, unless or until it is stated for the other isotopes, it is always 1 U. So that we will also learn in our next chapter. For helium, it is doubled. For lithium, slightly higher than doubled. A student, here we need to keep in mind or we need to highlight these things. The helium, okay, this one, the neon, this one, and the argon. A student, mark that argon also, this one. So these 3, in addition to that, there are xenon and radon also. So these are called as inert element. Means they do not react. They exist in nature as atoms. They are not forming the molecules. So why that? More explanation we will learn in next chapter. But for this chapter, we have to keep in mind these 3, like our helium, neon, this is argon, this much. The other element are also say xenon, Radon is also there, Rn. So these are called as inert or noble gas. Gas means it exists in gaseous form. Inert means they are not reacting. Noble means they are very much stable, they are not reacting. So these are exists in nature as free atoms. Means their atoms are stable, so they do not combine. Means their molecule, whether you say for the molecule of this element, so no molecule means it exists as the atom itself, means exists as atom, means free atom. They are not forming the molecule. So if I am talking for helium, so helium, if it is required to write, I shall write He only. Neon as Ne only. But for oxygen, denoting the oxygen, we are using the symbol O. But for reaction, we need to take this oxygen, the form in which it is existing in our surrounding, then two oxygen combines together to form O2, and this exists. So in reaction we are taking O2, not as O. Okay, but helium do not undergo any reaction, so we are not writing in a reaction. But for denoting, if it is required to denote in free existing form, still we need to denote it by He only. Okay, this thing we will learn in more detail in our next chapter. But here itself we need to mark these three elements, or rather these four elements. These are our inert or noble gas. They exist as atom in nature. Means they are monoatomic molecule. You may write it is our mono means one, monoatomic. But oxygen always exists as O2. Means two atom of oxygen must combine. So 2 is denoted by term di. So diatom means it is denoted as diatomic. So what is this monoatomic? What is diatomic? How these elements combines to form the molecule, those things we are going to learn. A student, before going to that, I want to make you understand one more thing. There is a magical number associated with this element called valency or combining capacity. That is called as ion formation. Okay, means positive ion or negative ion. What is that? That we will learn later. But here we need to keep in mind something, that this hydrogen have the tendency to form either +1 or -1. Okay, means the hydrogen ion can carry 1 unit positive charge, either in positive or in negative. It is that one. Helium, since they are existing, they are stable, so no valency or no charge. But lithium, if you consider, you always have to keep in mind 1 unit positive charge. Means one, while this lithium will try to combine, it will always combine with one of the atom by losing one of the electron or by forming 1 unit positive charge. How it will form? How is that? Those things we will learn today in ions. But what is this number? This number I want to keep in this table itself, so that it will be easier for you to remember. Beryllium, if you talk for the beryllium, it is able to form +2. A student, coming for the boron, it is able to form 3 ions. Mostly they are the positive, so write +3. Coming to the carbon, it cannot be plus or minus, but it can show 4 electrons. Means what is this electron? That we will learn later. The atom itself contains the electron, and electrons are involved in making the molecule. So how is that electron? How is that arrangement? That we will learn later. But here we have to keep in mind, whatever this serial number, from the serial number 1, 2, 3, 4, we can anticipate this. Coming to the nitrogen. So after these 4, none of the element have charge carrying or sharing or valency more than 4. Here we are observing in positive it is first increasing, then reaching to 4, which cannot be positive nor negative. After that you have to decrease again back with negative sign. So nitrogen, from this 4 it will be -3. For this oxygen it will be -2. What is this number? I will explain. Okay, how is the charge? Fluorine, it is our -1. So this charge carrying, or this is called the valency, this we have to keep in mind, student. It will be used throughout our chemistry. So this is another useful data we need to keep in mind. Now neon becomes 0, means its valency or combining capacity is 0, like helium. That's why it exists as free atom. Now coming to the sodium, again it will increase in positive, means like +1. The sodium have this valency, or this much charge this sodium can carry, 1 unit positive charge. Magnesium can carry 2 unit positive charge. A student, whether you write as +2 or 2+ mean the same thing. Okay, coming to aluminium, aluminium can carry 3 unit positive charge. So either +3 or 3+ mean the same thing. Coming to the silicon, it become again 4. So it cannot be positive or negative, because tetravalent are neither positive nor negative. More detail we will learn in class 10. Coming to the phosphorus, again start decreasing this. It become how much? In negative, -3. Good. For sulfur, how much will be the charge carrying capacity or valency?
-2.
Good. So it become -2. Then go for the other. So for chlorine, how much it will be? -1. Good. For argon, how much it become? 0. Means no combining capacity. Okay. Then again it will continue to increase. So this way it is continuous variation. This number and this table, once you understand, chemistry become very easy. So that's why we need to keep in mind. It is +1 or 1+, or simply plus is written, it simply means that. For calcium it become again +2 or 2+. Up to your level, only this much is enough. A student, some more we have to keep in mind. Say for barium, it is our +2. This also we need to keep in mind, because barium chloride we will form. Here today or even next day we will learn one positive and one negative just combine to become neutral. That is the way of writing the formula. So this number is very much magical and very important. Chlorine, again it is the bromine, brother of chlorine. So it have -1 or 1-. Copper, it have +2 in general. It may also show +3 like that. Cobalt, also +2. Coming for the iron, it can show 2 kind, either +2 or +3. It have, or it can show 2 kind of valency. It is called as transient element, transition element, that we will learn later. Gold, lead, no need to mug up for the gold, though it is +2. Mostly all of these have the +2. Zinc oxide like +2. Uranium, leave it. Mercury, so it is also +2. Other have the +2. whatever we have written, it is this one. So these are the numbers that we need to keep in mind. Now student, how to determine this number, whether positive or negative, or what will be it? So a student, you just keep in mind the important noble gas where it is. From here you are getting, if it is just after, means for a given noble gas, say argon, after this the next 3 will be +3, and just before this it become minus. So just 1 before it, -1. See, 2 before it become -2, 3 before it -3, but 4 before it only 4. Similarly, if you consider the neon, for neon, here we are observing after this the first one is the sodium, so +1. So keep in mind the number or the number for helium, neon, argon in your mind, and just observe what is the sequence number of other element. 1 before the neon, here we are observing -1. 2 or 3, say aluminium, aluminium coming where? So a student, if you have this serial number in your mind, then say for aluminium I want to determine how much is the charge. So I am knowing that neon is about 10. So it is about 10. The serial number I am writing 10. Means it is about 0. Then after this neon we have sodium, magnesium, then this. So sodium have this +1, magnesium have +2, then aluminium will have +3. So this way, if you are missing, if you could not remember directly, indirectly you can determine what will be the charge carried by the atom. Say for oxygen, where is that? Oxygen. How is this? So a student, if we consider the oxygen, we are knowing that oxygen, then there is, after this oxygen we have the fluorine, then neon, and we are knowing neon have the 0, fluorine is before it, -1, so oxygen will have -2. So I shall keep in mind the charge carried is -2. Are you getting a student? So this way the charge you have to determine quickly. Students, so therefore for forming the ion, this charge is denoted over that ion. Say oxygen ion I have to denote. How I will denote? So oxygen, and over this I will write 2 minus, or I may denote O minus minus, or even if I am denoting O -2 mean the same thing. So considering the ion formation, this number is very important, that we have to keep in mind. So what are these ions? How is their number? Those things we will learn in more detail. Aluminium ion, if I want to denote the aluminium ion, what it become? Al will be the symbol, and 3 is, so write as the 3 plus. Okay, say sodium ion I have to denote. So sodium +1, so I shall put Na plus or Na1 plus, mean the same thing. Okay, so 1 is not written in general, so only Na plus is preferred. Okay, magnesium. So magnesium denoted by Mg, but it carry the 2 unit charge, so 2 plus. Just wait.
Hello.
Yes, I am here. Don't worry. So this way, how the elements are forming their ion, those things also we have to keep in mind. For that, how is the number I have written in this table? So we will come back to this later. So now let us go for how the molecule and what is molecular mass before framing the molecular formula. So for framing the molecular formula, I need to understand these atoms in their ion form, which kind of ion it will form. Say you can take anyone, say for nitrogen or for chlorine, anyone you can take. Say the chlorine, which kind of ion this chlorine will form? A student, say the ion formed by chlorine will be Cl, and what will be the sign? So ion is our -1. Argon, no ion. So argon will always be denoted as Ar only.
AR.
But for potassium, what will be the ion form? K plus.
Potassium +1.
Very good. For calcium, what will be the ion?
Pa+2.
Good.
plus
Ca 2 plus or +2. So this ion we are writing, it is very important. Barium, if it is required, then Ba 2 plus. Bromine, it is Br 1 minus. For copper, Cu +2. For zinc is the other important one. So the symbol will be Zn 2 plus. So student, these ions form directly, we have to keep this ion in our mind. So for hydrogen, I may denote it H plus or H minus. Two kind of ion is formed by the same element. It is only and only hydrogen, which shows a bit peculiar behavior. Lithium, the ion form will be Li plus. For beryllium, the ion form will be
Be +2.
very good, 2 plus. For boron, B3
B
plus.
+3.
Yes. Carbon, a student, if you are denoting carbon, then you shall not write 4 minus or C4 plus. No. A student, so for carbon, you have to just put in the bracket without any sign. It will show the valency 4, but neither positive nor negative. They are forming the covalent that we will learn later. If there is nitrogen, it means nitrogen 3 minus it can form. Oxygen ion, how much?
O-2.
Very good. O2 minus. For fluorine, what will be the ion form?
F-1.
-1. Yes, a student, for sodium, what will be the ion?
Na+1.
Very good. Na plus simply. For magnesium, the ion form will be Mg
Mg+2.
plus. For aluminium, the ion formed by aluminium will be denoted by Al
Al(3).
plus. For silicon, we just denote as silicon (4). For potassium,
P-3.
sorry, phosphorus, P. Very good.
P-3.
For sulfur, S.
S-2.
-2. A student, from here we have to keep in mind, I shall never take, say, oxygen as O minus. This I shall never take. If I am going for making the molecule, I shall always consider O with -2 unit charge. Similarly, for nitrogen, I shall not take N2 minus. It become wrong. What I shall take? N3 minus for making the molecule. So these numbers are very important. It is considered by taking the reference of these inert gas, okay, and their serial number. We will learn later. This is basically determined by considering or making their electronic configuration. But electronic configuration belong to your next chapter. That's why, to keep you understand or keep you in mind, so this technique is enough to keep in your mind. What will be the ion form? Aluminium, say, a student, how I shall denote the aluminium ion? Al plus or Al2 plus or Al2 minus or Al 3 plus, what should be the symbol for aluminium ion? Can anyone tell me? Can I write Al plus?
Al plus
3.
3.
Al plus 3.
Very good. So for aluminium, the other structure drawn like this one is our wrong. This is also wrong. This is also wrong. So this is the correct one. Okay, means Al 3 plus. Get it? So this way, which kind of ion it will form or an atom will form, that is determined by their serial number. In beginning we had written, and referring this inert gas or inert element like helium, neon and argon. For you, only 20 are enough. Okay, argon. So just after this, the next three will be formed plus 1, 2, 3, and before 3 means 3 preceding element minus 1, minus 2, minus 3. This is the technique to keep in mind. And after knowing these ions, we are able to understand the various kind of cation, anion, I mean positive charge ion, negative charge ion, and then they have to combine to form molecule. For going in more detail, let me just explain one example here. A student, the general tendency of any molecule is to remove their ionic characteristic. Means one positive ion will get connected or get attracted by a negative ion to form a neutral one. A student, consider this. Sodium and chlorine want to combine. How they will combine? So sodium have a tendency to form which kind of ion? Na plus. Okay. Chlorine have tendency to form Cl minus. Okay. Here we are observing one positive, one negative. So if they are coming closer, they will neutralize and NaCl is formed. Is it okay? But if we are considering the second one, say magnesium and chlorine, this I will explain in more detail after learning the ion. I want to show you what is the use of this ion that we are denoting. Okay, or the charge or the valency we have considered. For magnesium, what is the ion form, student? Mg. In ionic form, how I shall denote this? Mg2 plus. For chlorine, how I shall denote? 1 minus.
1 minus.
Minus 1 or 1. So what you have to do for writing the formula, you have to just keep in mind, these 2 unit positive charge have to be neutralized by negative charge. It means how much negative charge I shall take? Since one magnesium itself contains the 2 positive charge, so for neutralizing I need 2 negative. Therefore this Cl 2 in number have to be taken. For that, writing the formula, what we are doing, this 2 is just brought below this, the next element or next ion or radical, and this is minus 1, so only 1 is taken here. So only this number means forget the positive and negative since they are opposite. So what are their number that we have to keep in mind? So it becomes Mg1 Cl2. 1 is never written, so formula become MgCl2. So student, we are always writing MgCl2 not as MgCl. Why? I had explained neutralization of their charge have to be done. So what all these things are, how these are done, these things we will learn today in more detail. Okay, student? So this table, their mass number, their initial serial number or atomic number, the ions form and means ions in symbol form, and the charge carried plus 1 or minus 1, minus 2, minus 3, these are very important. A student, so how the molecular form that we will learn later, but we have to learn a small topic before that, what is called as the molecular mass of element. Okay, student? So let us consider the molecule formation. So student, write it. Molecule formation. How is this molecule formation takes place? Those things we have to understand. Students, we had learned that molecule must contain more than one atom. It is the prime requirement. Means if more than one atom combine together or get linked together or get bonded together, it will form the molecule. Now, this more than one atom, what does it mean? It may be your two or more atoms, they are linked together. So linked. So this link is called the combination or chemical combination or combine to form molecule. So how is this? For understanding that, we have the radical that we will learn. Now see, a student, either there should be at least two atoms or even more than two is also okay. A student, if we are considering only two atoms, then these two or more atoms may be of same type, means two or more atoms of same type. How it could be same type? Means same element, student. It simply means that. Or different element or different elements. How is that? So it may be of the same or maybe of the different. Okay, means considering the elements only, the molecule may be formed. Example, if we consider the oxygen, oxygen is what? Oxygen is one of the element. It simply means. So the symbol for this oxygen is O. Okay, but this O do not exist in nature. So two oxygen atoms combine together very quickly. Combines to form one oxygen molecule. Means what? This one oxygen atom and other oxygen atom, they will combine very quickly. Means in isolation, this oxygen atom do not exist. So it always exists in the form of O2. So here we have written in the form of two atoms of oxygen.
One molecule.
But it is one molecule of oxygen. Okay, student. So here what we are observing, that this molecule may be of one element. It is one example that I have taken, but it is also possible. Let us take the other example. Example number 2. I may take the carbon as one atom, then it is found that it can react with one molecule of oxygen or two atoms of oxygen, you may write. Okay, then it can form carbon dioxide. This is CO2 is called, the chemical name is carbon dioxide. Students, so this carbon is atom. So this is one atom of carbon. Carbon is again what? It is the element. This oxygen is what? One molecule of which one? Oxygen, student. This oxygen is also what? Element.
Element.
But this CO2 is what? It contains two different kind of element. So when the molecule formed of different kind of element, then it is called compound.
Compound.
Yes. So one molecule of a compound. What is this compound name? The name of this compound is carbon dioxide.
Carbon dioxide.
So this way we have understand that the molecules may be for the element only, or this molecule may be for the compound. Okay, and atoms surely be of the element only. Atoms cannot be of the compound. This I was trying to explain even the day before last lecture also. Okay, student. So here we have to keep in mind that the molecules may be form of the element itself. So oxygen is element itself. Okay, student. So that's why we are commonly considering the two topics here. The topic what we had considered was molecule of elements and molecule of the compound. Are you getting? What do we mean by this? So molecule of elements means I shall consider the element which is forming the molecule. But if we are considering the compound, it means we need to consider two different elements. Then it will form the compound. Is it okay? So this is what we have to learn today. So student, here we have observed what is our conclusion. Let me write. Two different elements combine to form the compound. So right here, two or even more we will also see different elements combines to form compound. It is
Compound.
yes, and the smallest formula of compound is called what? The molecule. So a smallest,
Molecule.
yes,
Molecule.
yes. So a smallest unit or formula of a compound is molecule. You have to write all those things, student. So these things are very important. Just once you will understand, throughout your life you will enjoy the chemistry. But if you are not understanding in class 9, then it becomes more difficult day by day. So the
Sir.
smallest unit or the fundamental unit of compound is molecule. We have also observed two elements may also combine to form a molecule, but that will not form the compound. Is it okay? So write that two or more atoms, two or more atoms of same element can also form what? Compound. Is it okay? So two or more atoms of same element can also form, what they can form? Compound.
Bound.
Student, I have told you two different elements have to be combined to form the compound, and the smallest unit of that is molecule. Student, I was explaining here also, oxygen combines together to form the molecule, but this molecule is, say, oxygen O2 is not the molecule of compound. This is the molecule of element, student. So therefore, we shall keep in mind two or more atoms of same element can also combines to form not the compound but molecule.
Element.
So molecule are of the two type. So here we have to write not the compound can also form molecule. So this molecule is molecule of the element. Getting no? Right? Not forming compound. Why? For compound formation, it must be different element, means different kind of atoms have to combine to form the molecule of compound. But if same kind of atom have combined, then they will also form the molecule, but this molecule will be of the element. So molecules may be of the element, or these molecules may be of the compounds. Ready? So these things are important to understand, students. Therefore, the two topic called molecule of element and molecule of compounds. So a student, here simply molecule means, so two or more atoms. So two or more atoms. It simply means that. Element means only one kind of atoms. This you have to keep in mind. Elements means only same kind of atoms. Same kind of atoms you need to consider. But for the compounds, you have to keep in mind different kind of atoms. So if we are considering different kind of atoms, means different kind of elements, it simply means that. So molecule may be form of the element or maybe of the compound. Example, if we consider, say, oxygen, then this oxygen atoms we are writing. It is found that two oxygen atoms quickly combine together, and it is written as O, and below that it is 2. So writing in this form, it is called as one oxygen molecule. But writing in this fashion, 2 before that, so it is our 2 oxygen what? Atom. So this is the difference. It means this is what? O2, N2. They are the molecules of which one? Atoms, a student. So write molecules of atoms. So molecules of atoms, it simply means, molecule of element, student. It simply means same kind of atoms, molecule of element, not the elements, or elements if we are considering the different type of molecule. So the same element you need to consider. So these atoms of same element get linked or combined. Example, it is found that two oxygen atom, they combines to form one oxygen molecule that we have written above. Okay, student, that is, if I'm writing like O, before that we are putting this 2, this is oxygen. So it is two oxygen atom in symbol form, one oxygen molecule denoted as O2. So oxygen molecule, if we are saying like that, it always means we shall consider O2 not as O. Why? Since O is what? It is oxygen. What is difference between this O and O2? It is oxygen atom. Yes. So it is one atom of oxygen. Students, so keep in mind, if you are writing O2, so you have to look at below suffix. So it is more than one atom. So one molecule of oxygen. But if it is simply written like O, then it is our one atom of oxygen. A student, if any place say it is written like 3O, then what is it represent? It represents three atoms of oxygen. Very good. A student, if any place say there is written like 4O2, what it represent?
4 atoms of oxygen and 1 atom.
Molecules of oxygen.
Yes. Once again, please tell me, 4 atoms or 4 molecule? A student, these
4 atoms and 1 molecule of oxygen.
Listen carefully. This 4 which is before O2. So you have to keep in mind this O2 is represent one molecule. This 4 indicates 4 molecule of oxygen. It simply means. If we count the total number of atom here, so here total number of atoms, if we are interested to know, then these 4 have to be maintained as it is. And since one molecule contain how much atom? 2 atom because of O2. So total 8 oxygen atom. Oxygen atom in this case. So this is asked in your MCQs also. Say 4O2 represent what? In term of molecule it may be asked, or in term of atoms it may be asked. So either you speak in the term of molecule once or in the term of atoms one. You shall not combine both atoms and molecule in same statement or in same language, otherwise it becomes wrong. Okay, student? So here I had taken the oxygen. A student, we have to keep in mind, if we are taking the, say for nitrogen, say nitrogen, then it is also found that this nitrogen, 2 nitrogen atoms quickly combine together to form N2. Okay, it is also found that, say if I am taking the other one, say chlorine, third one, chlorine element, then it is also found that 2 chlorine quickly combines to form Cl2. So here we are getting on this side 2 atoms of chlorine. And this side is one molecule
One
of
molecule of
chlorine.
chlorine.
Okay, student. So here I had considered the same kind of element. So these are the molecule of, it is what? So these are the molecule of elements. But if I am considering the different elements, say molecule of compound. So for compound formation, I need to consider different elements. So compound means different element we need to consider, at least two or more. So student, if you consider the carbon can react with molecule of oxygen. Oxygen is what element? So it is the first element, though this carbon is in the form of atom. This is our second element, though the oxygen which exists in the form of molecule, but this carbon exists in nature in the form of atom. But both are the element in left hand side. They combine to form CO2. So this CO2 is what? It is one compound. So it is a compound. So this compound is called as the carbon dioxide. The name of this compound is your carbon dioxide. Carbon dioxide. So what are the constituting element? Based on that, the name of compound is given. So carbon is there. So carbon is taken. Oxygen is 2 in number. So dioxide is written. Here we are getting, this is the molecule or one molecule of which one? Compound. Okay, student? It is like this. A student, we can also understand like this. The second example, let us consider the nitrogen. Nitrogen exists as N2 and hydrogen as H2, and it is found that these two can combine to form NH3. Okay, how this NH3 is formed, that we will see later. For balancing this, I need to put 3 here, I need to put 2 here. Observe this, is it balanced? See, 2 hydrogen atom on reactant side, 2 nitrogen atom on reactant side, 2 nitrogen atom on the product side, 2 3s are 6 hydrogen atom on reactant side. This 2 is also for this hydrogen. So 2 3s are 6 hydrogen atom on product side. So it is balanced. How is this balancing? This we will learn in class 10th. Okay, student? So right now we have to keep in mind, just by trial we can check. A student, here we are observing. So it is the, how much molecule of nitrogen? 1 molecule of nitrogen. Good. So this is the molecule of element or compound. Say if I am talking for the nitrogen, so 1 molecule of nitrogen is an element. So
Element.
molecule of elements combines to form molecule of compound. It is how much molecule? Though hydrogen molecule means H2 we are writing, means it is our hydrogen molecule simply. But how much hydrogen molecules are there? It is decided by this
3.
number. So it will be 3
Three
molecules of
hydrogen.
very good hydrogen. And what is this form? In this case, we also have to keep in mind these two represent the number of molecule. But which one molecule? This is NH3. This NH3 is called as ammonia. Student, this is called as ammonia. This compound is called as, have the common name called ammonia. So this way we can write here, it is a compound which is formed and it is two molecule of ammonia, a compound. But here hydrogen and element. Here also nitrogen and element. So the atoms of elements combines to form compound. Means different kind of elements or different kind of atoms have to combine. But if same kind of atoms combine, it will form the molecule of element only. Okay, student?
Element.
Yeah. Another important thing that here we have to keep in mind, how to count the molecule that we have learned. If rather than molecule, if I want to understand in the term of atoms, how much nitrogen atoms are there? So this is nitrogen molecule, but this
Two.
N2 is formed by combining two nitrogens together. So these two nitrogen together is written as N2. May this N2 represent two atoms of nitrogen also. So I shall either write one molecule of nitrogen, or I may also talk in term of atom. So it is two atoms of nitrogen. Though these two atoms of nitrogen is present in molecular form or one molecule, like here I had written. So two atoms of nitrogen. So these have combined together to form, this is how much? One molecule of nitrogen. So we are considering whether I'm considering one molecule of nitrogen, it is equivalent to two atoms of nitrogen. Similarly, if I want to count total number of atoms here, how much? Here we are observing 3. But each molecule contain how much atom, student, of hydrogen? 2. So ultimately,
Two.
this 3 molecules means 3 into 2 atoms
Atoms.
of hydrogen.
6 atoms.
Good. So how much total atoms are here? Here 6 atoms of hydrogen. This we have to keep in mind. A student, if I want to count the total number of atoms here, then how much atoms? So how much total atoms here? That may be of different kind. So count. A student, we have to keep in mind, whatever this prefix 2 we have taken here, say this 2 we are taking, the 2, this 2 is for this nitrogen, and this 2 is also for this hydrogen. Like before the bracket, whatever the number we are giving, it multiplies all the term inside the bracket. So it simply means, so we have to count the nitrogen atom. So let us count one by one, then we shall add here. So here nitrogen atoms, how much nitrogen atoms? A student, this 2 and N is written only once, no N2 on this side. So it is our 2. Coming for this hydrogen atom,
3.
a student. So here we are getting these 3 for this hydrogen, but these 2 also need to be multiplied. So first you need to take this 2, which is means this 2 I have taken, which will multiply for each atom, and the last, the suffix or end, there is 3. So total 6 atoms of hydrogen. Therefore, total atoms how much? Total atoms, these two, means here we need to
Wait.
consider these two as well as these 6. So it is our 2 plus 6. Total
6.
how much, student?
8 atoms.
8. Very good. So here it becomes our 2 plus the 6. So 8 atoms. Are we getting? So this way we can count number of atoms in any molecule. So number of atoms in any molecule is called atomicity. So we have reached to another topic called atomicity. Student, write down the topic atomicity. Student, keep in mind. So atomicity is always associated with any molecule. So it is always of any molecule. Now, student, this molecule may be of the element or maybe of the compound, any molecule. So this molecule may be of element or compound. These things. So what is this atomicity? Write down the definition. So the definition is very simple. Atomicity simply tells the total number of atoms in a molecule. It's so simple, student. So it simply tells us how many atoms are there in any molecule. Just by that we can say the atomicity. So write down the definition. Atomicity, so write atomicity of any molecule is the total number of atoms present in that molecule. Means one molecule you have to take. Molecule means the molecular formula we will write. Then you have to count total atom in that molecule. Atom in one molecule. So it will give us atomicity only of that molecule. Atomicity of that molecule. So understand this. Example. Let us consider oxygen. So oxygen exists as in form of, how it exists? O2. Getting a student? So this, how much atom in this? O2 is oxygen molecule, student. But how much atoms are there? It is these two which is representing 2 atoms. So this indicates, so at oxygen in form of O2 contains 2 atoms of hydrogen. Sorry, of oxygen. Here we have considered. Therefore, what is atomicity of O2 is how much? 2. So whatever these atoms present, that will represent the atomicity. Let me take other example. A student, oxygen also exists as O3. This form of oxygen is called ozone. Whatever the ozone layer we have listened or we have heard about, which is present in upper atmosphere and absorbing the ultraviolet light, means protecting us from the harmful effect of ultraviolet ray. The same oxygen, the molecule present there is O3. So this contain how much atom? Yes, student, can anyone tell? Very good. So this contains
3.
3 atoms of oxygen. Therefore, if anyone is asking to you what is atomicity
3.
of ozone, rather than writing the formula, if only ozone is written, this is asked in your MCQ, what is atomicity of ozone? It is
3.
okay, student. Likewise, we can write anything. A student, if there is only 2 atom or only 1 atom in the molecule, it is called as monoatomic. If there is 2 atom, it is called as diatomic. Di simply means 2 atom. Here, if we consider the ozone, it is the 3. So this 3 word in chemistry is written as triatomic. Okay, student. Let me take the other one. Let us consider the ammonia. What is the formula of ammonia? Just we have written.
NH3.
3 NH3.
Very good. So the formula for ammonia is our NH3. If anyone is asking to you what is the atomicity of ammonia, yes, student, what you will tell?
3.
3. How? Atomicity. How much total atom present in this molecule? Please tell me.
8.
8. How is that? It is not 2 times of
6.
NH3. It is only 1. A student, understand. These contain how much nitrogen? For nitrogen, nothing is here.
One.
It is only 1. Contain 1 nitrogen atom. And how much hydrogen atom?
3.
Good.
3.
A student, so for each kind of atom, how much atom is present, that is written after that. And 3 hydrogen atom. So total number of atoms in this will be this 1 plus this 3. So 1 plus 3 is equals to 4. 4 is the correct answer. Are you getting? Let me take one more. If we consider say carbon dioxide. Carbon dioxide. A student, what is the formula? CO2.
CO2.
So how much atoms or what will be the atomicity? Can you tell me?
3.
3.
3.
Very good. So carbon is 1 atom, but oxygen is 2 atom. So just add it. 1 plus 2 is 3. So atomicity is 3. Are you getting? Very good. Now you people have understood. Let me take the 5th one. Say for nitrogen. Nitrogen molecule. If it is written like this. A student, how nitrogen is existing as N2? So what will be its atomicity?
2.
Very good.
2.
Here we are observing nitrogen is existing only 2 atoms. So 2 is the answer. A student, there are other elements. So take the 5th one. So if I am considering the phosphorus, it is found that phosphorus exists in the form of P4. not as N2, not as P2. Therefore, what is the atomicity?
4.
4.
Very good. The same 4 that we are observing. Let us take the 6th one. So wherever the atomicity is 4 in number, it is called tetraatomicity or tetraatomic. Okay? Let us consider the other, say, sulfuric acid, uric acid. The formula for this is H2SO4. A student, here you have to count all the possible kind of element. Very first is the hydrogen. Hydrogen, how much atoms are there? It is represented by the number below it.
2 atoms.
2 atoms. Other element is your sulfur. How much is there?
1
Nothing
atom.
is written here, means it is 1.
1 atom.
Very good.
1 atom.
Oxygen,
4
how much?
atoms.
4 atom.
Very good. So what will be the
Total 7 atoms.
atomicity?
7
7.
atoms.
Very good. So just you have to add 2 plus 1 plus 4 is equals to 7. 2 plus 1 plus 4 is equals to 7. 7 is the answer.
7.
And now you people are able to determine. Let me tell me one more. Sorry, the 7th one. Because whatever I am teaching, it is the complete one. Once you understand this, it becomes enough for you. Say atomicity for say C3H8. This is one of the compound that we will learn later. The name of this compound is propane.
Propane.
Yes. So what is the atomicity for this propane?
11 atoms.
Very good. Here we are getting carbon is 3. So these 3, hydrogen is 8. Adding these 2, we will get 11 as the answer. Are you getting? Now, let us go for the 6th one. Sorry, after this 8th one. Atomicity, if anyone is asking to you, atomicity of noble gas or inert gas. Inert, also called as noble gas. Like what they are, these noble gases, their name we have to
Helium,
keep in mind.
argon,
Good. Helium, another one is neon,
neon,
another
argon,
one is our argon, another one is xenon, radon, and krypton is also there.
radon,
So radon and kryptons are also there, and Kr, it is also there. So for this, what is atomicity? So how it exists in nature? So student, this inert gas exists without combination because they are not combining. Without combination means without combining with other element or with themselves, that is as single atom. Single atom. So if anyone is asking what is the atomicity of hydrogen, then hydrogen is existing as H2, you will write 2. But if it is the helium, what you will write? A student, you are knowing that
1.
helium exists as He only. It do not combine because it has 0 charge or 0 valency or 0 combining capacity. So it itself exists as He only. So atomicity is equal to how much, student?
Yes, it is equal to 1. 1 atom.
Very good. So it is 1 is the answer. If anyone is asking to you atomicity of argon,
R1. It is equal to one atom.
Good. A student.
AR1.
This simply means it is one atom AR. So this simply means atomicity is equals to 1. So for all these, we have to keep in mind atomicity of inert gas is how much?
1.
So this is asked in your MCQs. So atomicity of inert gas is 1. This you need to keep in mind. Okay, student. What are the inert gas that I have also written here? Hydrogen, neon, sorry, helium, neon, argon, krypton, xenon, red. Okay. So, a student, this thing we need to keep in mind. This way we have learned about the atomicity, which simply means how much atoms are there in that particular molecule. So that we have learned today. Sorry. So it is atomicity of inert gas. This you need to keep in mind. Okay, student. So it was all about our atomicity. A student, here we need to keep in mind few things. If the atomicity is 1, it is called as monoatomic. Monoatomic. So name of atomicity based on the number of atom. So atomicity type. So it is based on number of atoms in their molecule. In their molecule. A student, very first type is what? Monoatomic. What is this monoatomic? Monoatomic simply
One
means
atom.
Atomic.
Which
atomicity
contains one atom.
is equals to 1. What are their example? Inert gas.
Inert gas or noble gas.
Yes, both mean the same thing. Like helium,
Argon.
neon, argon, krypton, sorry, xenon. A student, the next type is our diatomic, called diatomic. A student, di means what? 2.
2.
Like mono means 1. This di means it is 2. So this di word, it simply
Atomic is equal to 2.
yes. So here atomicity is equals to 2. What are their example? Here we have
Oxygen.
learned yes, O2,
Oxygen.
N2, Cl2, other hydrogen H2. Okay, all these are existing as diatomic. Even F2, fluorine, all these things are existing as diatomic. The third one is called as our
Tetratomic.
triatomic. Triatomic. The word tri simply means it is 3. So if atomicity is 3, it is called as triatomic. What are their example? Can you give me?
Proton.
Yes, O3. So O3 is a triatomic. It may be, if I am considering CO2, how much atoms are there? 3
3.
atoms, 2 oxygen and 1 carbon. Okay, student. The other one, if there is 4, it is called as tetraatomic. What they are?
NH3.
They are like Very good.
Atomicity is equal to 4.
Very good. It simply means atomicity is 4. Example,
Phosphorus.
tetraatomic we had written. Yes,
NH3.
P4, the simplest one. Another, yes, for heteroatomic means different kind of atom considering that molecule, it is NH3. Okay, it is like this. A student, there are other one also, like if you consider this sulfur, then it is found that sulfur S exists as S8. Okay, phosphorus, here we have written phosphorus exists as P4 and it can also exist as P6. So if this phosphorus is in form of P4, then their atomicity is 4. But if it is
4.
P6, in this case the atomicity is
6.
very good. So atomicity may vary for different element. For the sulfur, what is the atomicity? Atomicity is 8. Okay, student. So this way today we have finished how the molecules are formed. For formation of molecule, what is required? Their mass number is required, which tells how much heavier. The very first one is atomic number. Considering the atomic number, the mass number will be formed. That mass number calculation and mass or the molecule formation we will see later. Means how is the molecular mass, that we will learn in our next class. So today we have learned about atoms, their atomic number. Then atoms combine to form molecule. Molecule may be of the element or may be of the compound. Counting the total number of atoms in that molecule, that gives us atomicity. So this was all about for today class. Yes, student, any student have any doubt, then please ask to me, students.